Watch this. A database is processing thousands of transactions per second. Bank transfers, e-commerce orders, real production traffic. An engineer walks up to one of the servers and unplugs it. Just pulls the power cable. Transactions keep processing. No errors, no downtime, no data lost. The engineer unplugs the second server, still running. This is CockroachDB, a distributed database that was literally designed to survive nuclear war. And it's the exact opposite of what we saw in Season 2. AWS DynamoDB, centralized coordination through US East 1. When that region failed, global services crashed. Google Cloud. Control plane failure cascaded everywhere. This is the story of how to build a database with no single point of failure. Why is it monumentally difficult, and when you actually need that level of resilience versus when PostgreSQL is just fine? Welcome to Season 3 of the Breakdown Economy. I'm Tony. We've covered multi-cloud strategy and chaos engineering. Now let's talk about the foundation of everything, databases. Because if your database goes down, nothing else matters. Traditional database architecture looks like this. One primary server handles all writes. Multiple replica servers handle reads. When you update data, it goes to the primary. The primary replicates changes to replicas. This works great until the primary fails. When the primary fails, you need to promote a replica to become the new primary. This is called failover. And here's where things get complicated. Problem 1. Detection time. How do you know the primary failed? Is it actually dead or just slow? Is the network partitioned or is the server down? Wait too short. You might promote a replica while the primary is still running. Now you have two primaries. Split brain. Data corruption. Wait too long, and your application is down while you figure it out. Problem 2. Replication lag. The replica you're promoting might be behind. The primary wrote data that didn't finish replicating. Promote that replica. You've lost recent transactions. Bank transfer that said it was completed? Gone. Order that confirmed? Vanished. This is why even high availability databases can lose data during failover. Problem 3. Geographic distribution. Want your database to survive an entire data center failing? You need replicas in different regions. But now replication is slower. Data has to travel across the internet. Network latency between regions is physics. You can't eliminate it. So either you wait for cross-region replication before confirming writes, slow but safe, or you don't wait, fast, but you might lose data when you failover. This is why even cloud databases have single points of failure. AWS DynamoDB is distributed. It runs in multiple regions. But the control plane that coordinates everything, that's in US East 1. When US East 1 failed in October 2025, Season 2, Episode 8, DynamoDB's control plane couldn't coordinate. Global services that depended on it crashed. Distributed data doesn't mean distributed coordination. The coordination layer is often centralized because distributed coordination is really hard. There's a fundamental theorem in distributed systems called CAP theorem. You can have two of three properties. Consistency. All nodes see the same data at the same time. Availability. Every request gets a response. Partition tolerance. The system works even when the network fails between nodes. You can't have all three. When the network partitions, you have to choose between consistent but unavailable and available but inconsistent. Traditional databases mostly choose consistency over availability. When they're not sure about the network state, they stop accepting writes. Better to be down than corrupt data. So, is distributed database resilience impossible? No. But it requires solving really hard problems. And one company actually did it. CockroachDB was founded in 2015 by former Google engineers who worked on Spanner, Google's globally distributed database. Their design goal: build a database that survives anything. Data center failures, region failures, even nuclear war. The name isn't accidental. Cockroaches survive everything. That's the point. Here's how they solved the distributed database problem. Solution 1. Raft consensus. Instead of one primary server, CockroachDB uses a consensus algorithm called Raft. Data is divided into ranges. Think of them as chunks. Each range has multiple replicas across different nodes. The replicas elect a leader for that range. But here's the key. When you write data, it's not confirmed until a majority of replicas agree they've received it. Let's walk through the process. Client sends write to CockroachDB. The range leader receives it. The leader sends the write to all replicas. The leader waits for a majority to acknowledge. Once the majority confirms, the write is committed, and the client gets confirmation. This is the consensus. The majority has to agree before anything is confirmed. Why this matters? 1. No single point of failure. Any node can fail, and the system keeps working as long as the majority survives. 2. No data loss on failover. Because the write wasn't confirmed until the majority had it, you can't lose committed data. 3. Automatic failover. If the leader fails, remaining replicas automatically elect a new leader. Takes seconds, not minutes. Solution 2. Geographic awareness. CockroachDB knows where nodes are located. It can place replicas in different availability zones, different regions, and even different continents. You can tell it. Keep at least one replica in US East, one in US West, one in Europe. Now, even if an entire region goes offline, AWS outage, data center fire, underwater cable cut, you still have a majority consensus in the surviving regions. Solution 3. Survivable zone failures. Standard deployment, 5 replicas across 3 regions. US East, 2 replicas. US West, 2 replicas. Europe, 1 replica. One region goes completely offline, still have the majority, 3 out of 5. The system keeps running. 2 nodes in one region fail, still have the majority. The system keeps running. You need to lose 3 out of 5 replicas simultaneously to lose availability. And even then, you don't lose data. Once the nodes come back online, they catch up. This is why CockroachDB demos by literally unplugging servers during live transactions. The database is processing hundreds of writes per second. The engineer unplugs a server. Transactions continue. 0 errors. Because consensus means the system was already designed for nodes to fail. It's not an exception case. It's the normal case. Solution 4. SQL compatibility. CockroachDB speaks PostgreSQL protocol. Same SQL syntax, same tools, same drivers. This is huge. You're not learning a completely new database paradigm. If you know PostgreSQL, you know most of CockroachDB. You can migrate from PostgreSQL to CockroachDB without rewriting your application. Change the connection string, done. Well, mostly done. There are differences, but the Surface API is familiar. All right, theory is one thing. So who's actually using this in production? DoorDash. Food delivery platform, millions of orders per day. They use CockroachDB for their order database. Why? Because when you're coordinating restaurants, drivers, and customers in real time, you can't afford database downtime. A single data center failure can't take down orders. Drivers keep getting assignments. Restaurants keep receiving orders. Money keeps flowing. And DoorDash operates globally. They need data replicated across regions with guaranteed consistency. CockroachDB gives them that. Comcast uses CockroachDB for internal operational databases. Telecom infrastructure has to be reliable. When you're managing millions of customer accounts, service provisioning, and network configuration, downtime is expensive. CockroachDB gives them multi-region resilience without the operational complexity of managing traditional database replication and failover. Bose is also a user because of their connected speakers and headphones, IoT device management, and their global user base. IoT platforms need databases that work everywhere. Users in Asia, Europe, and North America. Their devices are constantly connecting, syncing, and updating. CockroachDB's multi-region capabilities mean low latency for users worldwide, with automatic failover if any region has issues. Here are some other industries using CockroachDB. Financial services. Transaction processing where data loss is unacceptable. E-commerce. Inventory and order management across regions. Gaming. Player state that must survive infrastructure failures. And SaaS platforms. Multi-tenant applications needing guaranteed uptime. The pattern: high-value transactions where downtime or data loss is unacceptable and geographic distribution is required. These companies are paying for resilience, and they're getting it. Now, CockroachDB sounds amazing. It survives anything, no single point of failure, SQL compatible. So why isn't everyone using it? Well, trade-off number one: complexity. CockroachDB is a distributed system. Distributed systems are complex. PostgreSQL. One server to manage, or a primary and a few replicas. Relatively simple. Most developers understand it. CockroachDB. Minimum 3 nodes for consensus. Realistically, 5+ nodes across multiple zones or regions. More moving parts. More to understand. More to monitor. If you're a startup with 2 engineers, you probably can't justify that complexity. Even if you use CockroachDB's managed service, we'll get to that, you still need to understand distributed database concepts. Trade-off number 2. Performance consensus has overhead. Waiting for majority acknowledgement before confirming writes adds latency. PostgreSQL single node. Sub-millisecond writes when the data is local. CockroachDB. Multiple milliseconds minimum, more if replicas are geographically distributed. Physics is physics. If your replicas are on different continents, light speed is your limit. Data takes time to travel. For many applications, this doesn't matter. A few extra milliseconds is fine. But for ultra-low latency applications, high-frequency trading, real-time gaming, some analytics workloads, the consensus overhead might be unacceptable. If you're doing thousands of reads per second with sub-millisecond requirements, CockroachDB might not be the right choice. Trade-off number 3, cost. Running 5 nodes instead of 1 costs more. Running nodes in multiple regions costs more. PostgreSQL, 1 beefy server. Maybe $500 to $1,000 per month for a solid production setup. CockroachDB self-hosted, 5 nodes across 3 regions. Easily $2,000 to $5,000 per month minimum. CockroachDB managed, Cockroach Cloud. Depends on usage, but significantly more than managed PostgreSQL. You're paying for resilience, and resilience costs money. And trade-off number 4, when you don't actually need it. Here's the uncomfortable truth. Most applications don't need CockroachDB's level of resilience. If you're building an internal tool, a blog, a small SaaS product with a few hundred users, PostgreSQL with good backups is fine. If your database goes down for an hour once a year, that's annoying, but not catastrophic. You apologize, you restore from backup, you move on. CockroachDB is for applications where downtime or data loss is truly unacceptable. For example, financial transactions, can't lose money. Order processing, can't lose customer orders. Healthcare records, can't lose patient data. IoT device management, can't have global outages. And multi-region SaaS, need low latency everywhere. If downtime costs you millions in revenue or regulatory penalties, or if data loss means customer lawsuits, then CockroachDB's cost and complexity are worth it. Otherwise, PostgreSQL is probably fine. Let's connect this to Season 2. Season 2 showed us distributed systems that weren't really distributed. AWS. DynamoDB, distributed data, centralized control plane in US East 1. Google Cloud, multi-region services, but coordination through central control that crashed globally. Cloudflare. Edge servers everywhere, but one bad configuration propagated to all of them. These systems called themselves distributed, but had architectural centralization that created single points of failure. CockroachDB is actually distributed. There's no master coordinator that everything depends on. There's no US East 1 control plane. There's no central configuration that can break everything. Consensus means every write requires majority agreement, but there's no single node that has to participate in that majority. This is what true distributed resilience looks like. And it's rare because it's hard to build. Here's the practical takeaway. Most companies shouldn't build distributed databases themselves. It's too hard, too complex, too much operational overhead. But you can use distributed databases as a service. CockroachDB Cloud, managed service. They run the infrastructure. You use the database. Still get the resilience, don't have to manage the complexity. Google Cloud Spanner, Google's version of the same concepts. Managed, globally distributed, strong consistency. AWS Aurora Global Database, multi-region replication with fast failover. Not quite the same level of distribution, but better than single region. When should you use a distributed database? Use a distributed database when 1. Downtime or data loss costs you serious money or breaks regulatory compliance. 2. You need a multi-region deployment for latency or compliance reasons. 3. Your data is actually critical. Losing it would be catastrophic. 4. You have the budget for it, not cheap. Stick with a traditional database when 1. Downtime is annoying but tolerable. 2. A single region is fine. 3. You have good backup procedures. 4. You're optimizing for simplicity and cost. Most startups, most internal tools, most side projects, PostgreSQL. Well-configured, properly backed up PostgreSQL is reliable enough for 90% of applications. Add streaming replication to a replica in another availability zone, have good backup procedures, and monitor it properly. That's enough resilience for most cases. But when you're DoorDash processing millions of food orders, or Comcast managing telecom infrastructure, or a financial platform where data loss means lawsuits, that's when you need CockroachDB's level of resilience. And the nice thing about CockroachDB being PostgreSQL compatible, you can start with PostgreSQL. Build your application, prove product market fit, grow. Then, when you reach the scale where distributed resilience actually matters, you can migrate to CockroachDB without rewriting your entire application. This is how it should work. Start simple. Add complexity only when you need it. Choose the right tool for your actual requirements, not the most impressive sounding technology. True distributed resilience exists. CockroachDB proves it. You can unplug servers during transactions and nothing breaks. You can lose entire regions and the database keeps working. No single point of failure. No data loss on failover. But it's complex, it's expensive, and most applications don't need it. In the next episode, the company that never goes down. Cloudflare had a major outage in Season 2, but their overall reliability record still beats almost everyone. Here's the self-healing infrastructure that makes Cloudflare one of the most resilient networks on Earth, and what they learned from failure. That's next week on The Breakdown Economy. I'm Tony. Build for your actual requirements. Start simple. Add complexity only when needed. And remember, distributed resilience is possible. It's just not free. Know when you need it, know when you don't, and choose accordingly.